This lesson is on naming covalent compounds. Now, when we're naming covalent compounds, we're going to learn how to name two types of covalent compounds. There are actually many more than two types of covalent compounds, but at this point in your chemistry career, you only need to name the two simplest. First is the diatomic covalent compound. Second is the binary covalent compound. The diatomic means two of the same element. Two of the same element. And then the binary is two different elements. Two different elements. And they're all going to be non-metal elements. Now the diatomic covalent compounds, there's only 7 of them. If you look on the periodic table, they are nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, plus hydrogen. So hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. These 7 compounds, if they are left by themselves, not bonded to something else, do not hang out singles. They hang out in doubles. So what you do is you simply take the name of the element, and that's the name of the compound. So I2 is named iodine. There's no change to the name, no prefix is added. N2 is named nitrogen. And O2 is named oxygen. So if you have any of these 7 diatomic compounds, hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, they are always going to be in pairs, and the name is just the name of the element. Now the other type is called the binary covalent compound. Now the binary covalent compound is made up of 2 different non-metal elements. Now they have to be both non-metal. If one of them is a metal, you have an ionic compound. Both of them are metals, you have a metallic compound. But if they're both nonmetals and they're different, they're a binary covalent compound. In this case, we use prefixes. We use prefixes to tell us how many of each element. So here we have a 4. The prefix for 4 is tetra. Here we have a 10. The prefix for 10 is deca. So we're going to take the prefix tetra and we're going to put it on the name of the element, which is phosphorus. So tetra, phosphorus, and then deca goes on to oxygen, but we replace the end of oxygen with IDE, so we get deca oxide. So the tetra is because there's 4 phosphorus, and the deca is because there's 10 of the oxygens. So when you're doing covalent binary compounds, you must use prefixes that match the number of each element. Here's one, SO2. Now the prefix for 1, now there's no number after S, so that means there's 1 of them. The prefix for 1 is mono. And the prefix for 2 is di. But here's the deal. We never use mono on the first element in a binary covalent compound unless that first element is oxygen. And in this case, it is sulfur. So we are going to actually omit the prefix mono because the first one is not oxygen. So we just have sulfur. Now we have di. We do have to use the prefix on the second one, no matter what. Di for 2, and then oxygen becomes oxide, so sulfur dioxide. Sulfur dioxide. Hey, here we have N2F6. The 2 tells us we have the prefix di. The prefix for 6 is hexa. Now, since we have more than one of the first element, we do have to use a prefix. So dinitrogen, and then 6 of the fluorine. Hexafluorine becomes hexafluoride. Hexafluoride. Because we always take the ending of the second element and change it to IDE. So we have dinitrogen hexafluoride. Now, the first element we only have one of, and that is fluorine. So the prefix for one is mono. We have one here of chlorine, and the prefix for one again is mono. Now remember, we have an exception. We do not use mono on the first word unless that element that comes first is fluorine. Now we do use the prefix mono on the second word, always, no matter what it is. So instead of monofluorine, we just have fluorine. But we do put mono on chlorine, and chlorine becomes chloride, so you have fluorine monochloride. And that is how you name binary and diatomic covalent compounds.